I'm going to walk you through example 2.3 on pages 42 to 43 of our text. And this takes the information on productivities and then we add an information about how long someone works, and then we convert it into our first graphical model. And I suppose if you know anything about economics and economists, we use a lot of graphical models. So this is our first one, the production possibility curve. And I'm just going to walk you through that same example as in the text, but maybe seeing it built up instead of just seeing the graph just done for you. We'll give you some tips on how to do these yourself, because this is what we're going to do on Tuesday. So you've got this one-person economy. We call them a Robinson Crusoe economy, even though we've got Susan here. And in these economies, you always have two goods. In this case, it's coffee and nuts. And so what we do is we draw the axes. You scale them according to the information in the problem, but we know we're going to have coffee on one axis. I'm going to follow the convention of the book, but it doesn't matter which good you put on which axis. So coffee is in pounds per day, and nuts in pounds per day. So what you do for these models is ask, okay, well, if Susan can put all her resources, or does put all her resources in coffee, how much can she produce? And we see her productivities are given by the problem. She can produce or gather 2 pounds of nuts or pick 4 pounds of coffee in an hour, but then she works 6 hours, so don't miss that piece of information. So she put all 6 hours into making coffee or picking coffee. She could get 6 times 4, 24. And that gives us, that's the maximum amount of coffee this one-person economy can produce. And then in these one-person economies with constant trade-offs, sometimes you see national economy models with constant trade-offs too. If it's a constant trade-off model, the graph is actually pretty simple. All you need to do is ask yourself, oh, okay, well, the other thing she could do is do nuts, and the other easy point on this graph, there's an infinitude of points, but there's 2 easy ones. The other easy one is, what if she put all her time into nut production? Well, okay, 6 hours, you can gather 2 per hour. 6 times 2 is 12, and we're done. Well, we're almost done. All you do, if you've got 2 points on a line, you just connect those 2 points to get the production possibility curve. And so the point where she could pick 12 pounds of coffee and gather 6 pounds of nuts, that's on. We could go through, we could go one by one, hour by hour. If Susan started at 24 nuts, 6 hours in coffee, she could move 1 hour out of coffee and start picking nuts. She'd end up having 1 less hour in coffee. That would be 4 pounds less, so that would bring her down to 20. But then she'd have 2 pounds of nuts, and so on. Every point on this production possibility frontier is following that logic. And watch out, these straight line single, just one good, one constant trade-off. These are really easy. You have to be careful though. You get used to doing these, and then you get one that's got an increasing cost, which is the other case we'll see. It's actually much more common in the world, but we sometimes just focus a little bit over much on the simpler case. Anyway, you got to know when you got a problem that's got a bowed out from the origin increasing costs model. And so be aware of that. I guess the last thing to point out is, last screencast I showed you the hard way to calculate opportunity cost. The easiest way is actually to remember what I told you in class. That is, the slope of the production possibility curve is the opportunity cost. Once you draw the production possibility curve for Susan, I should give her name Susan. Later on we'll have Tom added to this model. But once you've done that, notice that the slope of this line is 2, right? 24 over 12. So the slope is -2 pounds of coffee over two pounds of coffee per pound of nuts. So the opportunity cost of a pound of nuts is 2 pounds of coffee. Remember, it's what we give up over what we get. And if you want to know, oh, what's the opportunity cost of coffee, though? If the opportunity cost is nuts is 2 pounds of coffee per pound of nuts, then the opportunity cost of coffee is a half a pound of nuts per pound of coffee. So done. That's actually, if you get a graphical problem, just graph it, concentrate off graphical problem, I should say, then look for the opportunity cost. Done. It's the easiest way.
Made with Doodlecast Pro.